Good day, everyone, and welcome to today's presentation. My name is MG Ekanaik from the Problem Solving Institute in Sri Lanka. I'm excited to have you here. Today, we'll be exploring the y equals f of x approach for problem solving through our second video in this series. Over the next few minutes, we'll look at how this method can help us analyze and solve various problems more effectively. So, let's get started and dive into this interesting approach together. Let's take a closer look at how to prioritize corrective actions effectively, especially when we think of it through the lens of the y equals f of x approach. What does that mean in practice? Well, it's about understanding the relationship between different variables and their impact on our overall process. By mapping out these relationships, we can identify which issues are most critical to address first. This approach helps us focus our efforts where they'll make the biggest difference, rather than spreading resources too thin. It's about asking the right questions. Which problems have the greatest influence on our key outcomes? How can we address the root causes rather than just symptoms? What's important here is that this method isn't just about fixing things randomly. It's about a strategic, data-driven approach. It helps us prioritize corrective actions that will yield the highest return on investment in terms of quality, safety, or efficiency. So, by applying the y equals f x approach, we can make smarter, more informed decisions about where to put our energy first, ensuring our corrective actions are both effective and efficient. Let's look at some examples for the y equals f x approach. This slide highlights how we can visualize and interpret different types of functions by examining their graphs or data points. The idea is to see how the output, or y, relates to the input x in various scenarios. By exploring these examples, we get a clearer understanding of the behavior of functions, such as whether they're increasing, decreasing, or have particular features like peaks or troughs. This approach is fundamental because it helps us connect the mathematical concept of a function to real-world data or phenomena. As we go through these examples, keep in mind how the shape and characteristics of the graph reflect the underlying relationship between x and y. This understanding is key to analyzing and applying functions effectively in different contexts. All right, let's walk through the key steps in our problem-solving process. First, we gather data by conducting surveys, which helps us understand the issues directly from those affected. Next, we select the most suitable problem-solving tool to analyze this data effectively. Then we determine the percentage contribution of each factor, like low harvest, technology issues, water scarcity, pests and diseases, poor market access, transportation and storage, and labor shortages, toward the overall dissatisfaction, which we label as why. This helps us identify which factors have the biggest impact. Based on these percentages, we propose targeted corrective actions to address the main issues. After that, we validate these corrective actions to ensure they're effective before full implementation. Speaking of implementation, that's where we put these solutions into practice. Now, to better understand the root causes, we find the factors contributing to farmers' dissatisfaction. From there, we develop a mathematical model that links these factors to the level of dissatisfaction, with y, farmers' dissatisfaction, being our dependent variable. By following this process, we're systematically pinpointing the issues, quantifying their effects, and designing effective solutions to improve farmers' experiences and outcomes. Let's start by gathering data through a survey to understand the key issues. Once we have the data, the next step is to select the most suitable problem-solving tool to analyze the situation effectively. We then determine the percentage contribution of each factor to the dissatisfaction, which helps us pinpoint the main areas needing attention. Based on these percentages, we can propose targeted corrective actions to address the identified issues. After proposing these actions, it's important to validate them to ensure they are likely to be effective. Once validated, we move on to implementing the corrective actions to improve the service quality. In our analysis, we've identified several contributing factors, including bureaucracy, complex procedures, water scarcity, lack of staff, lack of resources, poor digital facilities, and political influence. For each of these, we find their specific contribution to the overall dissatisfaction. The ultimate goal is to understand the factors causing dissatisfaction and develop a mathematical model that links these factors to poor government office service. In this model, our dependent variable, or Y, is the level of poor government office service, which we aim to improve. By systematically analyzing these factors and their contributions, we can create a clear pathway to enhance service quality and meet public expectations more effectively. Let's talk about how to prioritize corrective action effectively. When issues arise, it's crucial to focus on the most impactful problems first. This means assessing which corrective actions will deliver the greatest benefit or risk reduction quickly. One key point is to evaluate the severity of each issue. Consider what could go wrong if it's not addressed promptly. Next, look at the root cause. Tackling the underlying problem often prevents recurrence and saves time in the long run. Another important factor is resource availability. Sometimes, we need to prioritize actions that can be implemented faster or with fewer resources, especially if they address urgent safety concerns. Remember, aligning your corrective actions with overall business goals and compliance requirements ensures you're working toward sustainable solutions. By applying these principles, assessing impact, root causes, resources, and strategic fit, you can make smarter decisions on where to direct your efforts first. This approach helps maintain focus, reduces risks, and ultimately leads to a safer, more efficient environment. Let's take a closer look at some of the key QC tools. First, we have various statistical tests like the proportion test, which helps us compare proportions between groups, and regression analysis, which allows us to understand relationships between variables. ANOVA, or analysis of variance, is used to compare means across multiple groups, while DOE, or design of experiments, helps us plan and conduct experiments efficiently. The t-test is great for comparing two means, and the variance test assesses the consistency of data. There are many other tools in this category as well, all aimed at analyzing data and improving quality. Moving on, the D method, also known as the 8D method, is a structured problem-solving approach that guides teams through identifying and eliminating root causes. The A3 method is a concise, visual way to document problem-solving and continuous improvement. The DMAIC approach, define, measure, analyze, improve, control, is fundamental in Six Sigma projects for systematic process improvement. Other tools include NCR or SCAR, which are used to document nonconformance issues and corrective actions, and ICPC, which relate to internal controls and process checks. There are many additional tools designed to support effective problem solving. Finally, it's crucial to not just have the tools, but to use problem-solving methods to analyze root causes thoroughly. Prioritizing corrective actions based on these analyses ensures that we address the most impactful issues first, leading to continuous improvement across our processes. All these tools and methods are interconnected, helping us focus on root causes and drive sustainable quality enhancements. This slide doesn't contain enough information. That's why we're moving to the next slide.